we discussed how to release artifacts to artifact libraries, I don't know how to call them, storage places, whatever. And as we discussed before, every programming language, they have their own traditional, the most convenient, the most popular place for open source packages. When you develop your own software, which is not open source, which is proprietary software, then you also will have something like a package manager, and not the package manager, package library, where you will also deploy your stuff. It will happen, it must happen. So it's just, again, inevitable step in a group development. What's important, one more thing which I didn't mention, is that releases, they must be immutable, in my opinion. What do I mean by that? In some programming languages, in some platforms, the releases are not immutable. It means that you can deploy the package there, and then you can just go to the storage and delete it from there. For example, RubyGems, if I'm not mistaken, RubyGems is exactly like that. So if I release something, then I can go to, oh no, you can deprecate. Okay, it's possible to deprecate, but it's not possible to delete. Then it's good. Okay, then I stand corrected. So releases, they must be immutable, which may not be the case if you deliver your products to your proprietary storage. So if you, for example, set up your own storage of Maven artifacts, the jar artifacts, and then your team, like 10 people sitting together, you deploy to this storage. At some point of time, you may decide, okay, this version we no longer need because it was a mistake to deploy this version, so let's remove that version from the storage. It may be okay if the team is very small, if you all know each other and you all agree that this is the right decision, it's okay. But if you develop in open source, Maven Central, as I just checked, NPM.js, RubyGems, they don't allow you to do that. So releases are immutable. As long as it goes there, it never can be taken away. And this is good and bad. You know, there are advantages and disadvantages of this situation. The disadvantage is that you can make a mistake. You can deploy something which you will never be able to take back. And sometimes the mistake may be very serious. For example, you deploy something with the secrets inside. So let's say you forget some secret passwords and codes inside your package, and you just deliver that package to Maven Central, and it will be there forever. Like nobody will be able to take it away. Maybe you will be able to send an email to them and ask, but I never tried. Maybe they will listen to you. But in general case, you will just put the product for public use, and that's it. So you should be very, very careful. The beauty of this situation is that you can definitely rely on the binary artifact there. Even if the library goes away, even if the author of the library decides that it's no longer open source, I don't want to maintain it, I want to delete it completely, it happens. You know this story with this JavaScript package. It happened a few years ago when the author of the library removed it from, but actually how was it possible if it's not technically possible? Maybe this feature is no longer possible. I don't know, but that was the story, that the library was removed, the JavaScript library was removed from the storage, from NPM.js, and many other libraries, they depend on this one, so they also stopped working. So it was a massive crush of the people were not able to release something new because the library is gone, and then these libraries also cannot work. So this should not happen if the releases are immutable. As long as they're there, no matter what the author thinks, no matter what the author believes, there's no way to take it away from the public storage. So, because if you rely on the GitHub, if you, for example, find some interesting package, interesting library on GitHub, and you use it from GitHub, some people do it like this. So you do git clone, you clone it to yourself, you do some modifications, maybe build it locally, then you basically begging for trouble. Because in the future, who knows what will happen to GitHub repository? GitHub repository may be deleted. It may completely change the content. You should not expect GitHub repository, the source code, to be stable there. GitHub repository is a fluent, is a very continuously developed, like we discussed before, is a very volatile source of information. We should not rely on it anyhow. We can completely rely on Maven Central. 100%. And also one more note which I wanted to give you before we go into deploying the live applications is I'll show you the badges which people usually use when they care about their users. Then it's a good practice to now let me remove this. It's a good practice to put this badge, a kind of badge, to your, well, first of all, badges are nice. I mean, I kindly suggest you, maybe this is my personal taste, but me personally, when I see a repository without any badges in here, then I just don't feel good about the repository. I just don't feel that the author is really, the author really cares about us users. The author really has some passion about what they being developed here. So I love the badges. Maybe I put them too much here, but this is not too much. This is just a few of them. So this badge is actually the badge which, if I click it, it will move me directly to the RubyGems storage, to the right version right there. And the badge is rendered with the right version in it. So the badge, when you put it to, I'll show you how it's done. If you put it to, this is the list of badges in here. So this one is the gem version. So basically it uses the service, this Fury.io, which connects to RubyGem, gets the version from there, and shows the version on the badge. For any language which I know, this thing exists. Something like that you can find. Something like that connector to the release, which will show you what is the right version. So for the user, it's easier. So when I use the software, I don't want to really spend a lot of time finding out what's the last version or what is the suggested version, what is the preferred version to be used. And it's not a good idea either to put the version into README text. So that would be a complete mistake if I say in the text, for example, I say this version, blah, 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 use, for example, you install, gem install, and then 0044. Some people do it like this. So you install, and then I specify the version. Everybody understands it's wrong, because tomorrow the version will go forward, and I will definitely forget to change this in the README file. That's for sure. So saying this in the file is a bad idea. What sometimes we do is, for example, in this in the takes, for example, framework, the Java, I can show you how we do it there. Takes. README, sorry. So the README intakes looks like this, blah, 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 and then it says quick start. Yeah, you see, it says if you're using Maven, then this is how your POM XML should look like. And then we say dependency, but this is not really true because it's not going to work like this. It's not going to work because we're missing the version tag here. So the version should be there, but I don't say it here because the version is what? What do I say here? I don't know what to say. Because 119 is wrong because tomorrow there will be 120, but who will remember to replace it here? Nobody. Sometimes we do it like this. Get it from releases page. We'll discuss this page in a second. Maybe this is also possible. But this one is, I think it's the safest and not the most user-friendly, of course, because the naive user who is not really familiar with Maven will probably use it like that and will definitely get the error from Maven. So Maven will not compile this configuration. It's wrong. Maven will complain and say, come on, version is missing. So you have to give me the version. And the user will just wonder where the version is coming from. I don't know the right solution. And the badge here seems to be like a good idea. It's a good solution, good concept for mentioning the version. So the user will just scroll the page and immediately will, well, not immediately, but probably will see the version. And you see the version is not really updated. It's 42, so it's 2 versions back. It takes some time for this badge to catch up. So it's not going to show me immediately what's the version. And let's take a look at the release notes, so-called. So in GitHub, they introduced a few years ago this releases page, where you can create, every time you release something, you may. It's not mandatory, because the tags and releases are different things. So the tags, as you can see here, they go from Git history, and they have their own commits. They have some text attached to them, but these commit texts are quite simple because Rulter is doing that, so there's automatically generated pieces of text, in my case. Some people write more detailed tag descriptions. But then tags and releases are different things. So tags, they are from Git history. You create them, but it doesn't mean that people who use your product, they will just go to releases and will see it there. You may have 100 tags and 0 releases, which is, in my opinion, kind of a little bit confusing, could be confusing for the user. So it's better to have one-on-one matching. I have a tag, and that's the release. I have a tag, and that's the release. And these release nodes, so-called, so each block like this is a release node. And these release nodes, they are created, in my case, automatically, because I'm too lazy to do it manually. So that's why the Rulter is made to create them automatically. So the title is taken from the title of the issue where the Rulter was running. And then there is a small text here which explains what's going on. So it says, see the ticket where we did this. This is release log. The full build log is here, and they attach, this is done automatically by GitHub. So they attach the source code of this release. So it is a good idea in general to write more detailed release logs, not like I do here, because this is just automatic. So probably proper way is to edit this and to explain what actually happened. Not this, not this very technical placeholder information, but actually say that in this version we released these features, and then you list the features and explain, like, I don't know, we render faster, we show better, I don't know, layout, and so on and so forth. So you explain to people what actually they should expect in this version, what it's for, what's the point of this. The point is that the user must decide. Well, in an ideal world, not in my world, but in an ideal world, every time we take a new version of the product, we read the release notes and we see, okay, what changed there? What's the new functionality? Why I should upgrade from version 0.1 to 0.2? In my world, I don't care, I just upgrade. I don't read release notes ever. I just upgrade, and if it doesn't work, if I jump from version 0.1 to 0.2 and it doesn't work, I mean, my code stops working, then I maybe check the release notes, but rarely, super rarely. So, in my opinion, this mechanism of release notes a little bit outdated, probably, because it came to us from, I don't know, from 80s maybe, something like that, when people didn't have GitHub, people didn't have automated releases, people didn't have even versioning. They were exchanging the code from, on disks, on diskettes, on floppy disks, and it was really interesting at that time to really read what's going on there. Like, there's a new version arrived from somewhere, and just open the file and you read, okay, what is there, and you really carefully review each version. Now we upgrade versions automatically, like we discussed before. These bots, the Dependabot, Renovate, all these guys, they just automatically push you the new versions every day, and you have no time, no desire, no wish to read the release notes. As long as the new code works, I don't care. Like, what is there? So in my world, I just have this automatically generated release notes, and bye-bye, that's it. Even when we release something really big, important, who cares? As long as it works, I would even maybe get rid of this release notes and stay with the tags. That's the tag, that's the description, that's the link to the issue, go to the issue. I mean, we don't have the link to the issue, that's not good, but make a link to the issue, then people go to the issue. In the issue, they read what happened. For example, here, so I can go in this issue, let's release a new version. Okay, in this case, it's kind of dummy, but that was the previous release, which happened basically yesterday. So it explains, okay, the life cycle, we introduce something, then I have the commit, you can check the commit, then the release happened, that's it. But GitHub has this release notes, so probably as long as it's there, I mean, it looks to me like a practice from 20 years old. And also one more thing, one more, in my opinion, again, outdated practice, it's called changes history. So some people maintain in their repositories, like they did many years ago, they maintain so-called release changes history. So when you get the package, from somewhere in your hands, then you open the package and you might expect to have a list of changes which happened previously over the last 5 years. And that is how it was a long time ago. I mean, it still happens in some packages when people were maintaining a separate file in the repository called changes.txt, or even the directory with the many files with the changes. And then it was possible to go through these files and see, basically there's a collection of release nodes, but in the many, probably shorter version of them. Now, as long as we have, it was okay, it was necessary when people didn't have Git, when people didn't have version control systems. Again, when people were delivering the software on floppy disks, I get the software, I open it, there's the file, which tells me, okay, what are the changes? Now, when I get the software, I go to GitHub and I see the changes. I don't need this list of changes. When I go to the current version, I can go to Git history and see how they changed, what they changed. So it seems that we have more automation now than before, and that's why release notes and changes tracking is kind of old system. I can show you one more thing, which is kind of quite exciting, which I learned just a few weeks ago. You probably know LaTeX system, right? LaTeX is the system for editing documentation, quite popular in academic world. All of you definitely either use it already or will use it. So for this LaTeX, there exists a number of, could exist, and we use in LaTeX many packages, so-called packages, which people develop. So anybody can develop a package for LaTeX, me as well, and then this package can be released and used by other people. For example, I made a package, I made a few packages actually, but I'll show you just one, which is quite exciting to see how it's built, how it's built together. So basically, the package is just in the end, it's just one file, just one .tex file or .sty file, which people embed into their own document, and their document look differently because they use commands which you provide. But how you prepare this file for them, it's very interesting. So they have so-called DTX file, which I see it, only probably in LaTeX this thing exists. So basically, this file is a combination of the code to execute and the documentation about the code. So you have, if you scroll down, I'll show you the good example. Let's see. This is the code. This is the code which will, let me run first so you understand what I'm talking about. So you run it like this. It does something. Okay, sorry. So I ask LaTeX to run this file, this DTX file, this one, which you just see here on the screen. And it does it. It says OK. And it generates for me the file which is called, let me show you what it did for me. It generated the file, oh no, hold on, it doesn't, it's not like that. I run it with this file, another one. Yeah, it generates the file which is called, with the extension STY. So this STY file, if you look at it, you will see that it contains, look at this code. And look at this code. This one and this one. So this is the target file, this STY. The file is generated taking the pieces from this file and ignoring the documentation about it. So all the comments we have here, they're just comments about the code, like in a normal programming language, like in Java, like in any place. So it's just a comment, this is the code. Again, this is the comment, this is the code. But what's interesting is that if you do it like this, then it will generate the PDF file. The PDF file here it is. This is our code, which you just saw, and this is the text around it. This is the before, this is the after. So it generates the documentation about the code. So I write the code, and I make the comments about it, I explain what I do, and in the end it generates the full file, which looks like a normal, very good looking PDF file, which is the pure which is the really documentation about this package. Very, very well formatted, very convenient. It's quite amazing to, it's really like makes a lot of fun to write the code. So you just write a piece of something and then you comment about it, like explain, here I'm doing this, here I'm doing that because of this and that. And you know that you don't write it for nobody, you write it for real users. Because in case of Java and many other programming languages, your comments just go nowhere in most cases. Nobody really read them, like really, really carefully read them. But in this case, you just write the documentation together with the code. I can maybe compare this with Rust, because in Rust, something similar, very similar exists. I'll show you now. I'll show you now how it looks in Rust. So this is one of the projects I work with in Rust, and in Rust actually we have something quite close to, again, the same feeling of documenting the code. Look, this is Rust. So you don't need to know Rust, but get the idea. So this is the code in Rust. This is the part of the code which is in Rust, which does something, blah, blah, blah. And this is the documentation. So the documentation contains the block, which is, this is the markdown. So this is just normal formatting, the markdown. I can do, for example, like this. You see? So it's markdown, so it makes it look, it formats the text. But when it sees the piece of code formatted like that, then it understands that what stays in this block is a Rust code, is a piece of Rust code, and when you run unit tests, it extracts this piece of code and executes it. So when you build together the Rust program, it compiles your main files, then it compiles your test files, then it runs your tests, and then it takes these pieces from your documentation and also runs them, and compiles them, and executes them as well. So it's like extra level of testing. They just test what you wrote in the documentation. I can show you like in practically how it works. Again, really, really interesting experience. Take a look. So I do cargo test. Cargo is the build manager, the builder, which will take a few seconds. So it will just compile everything and prepare, and then we will just intentionally make a mistake in one of these lines and see what we'll say. So this is like a direction to where people are moving now. I mean, from LaTeX it's quite old. They were using this for ages, but in Rust it's quite fresh. I mean, I haven't seen this in any other programming language. Maybe I missed something, but you will see now You'll see now what's going on. So, again, so what happens when I do Rust test? First, it compiled everything. Now it says running 35 tests. So these are the tests which I wrote. Test. They're just the test which I have. My 35 tests. And it says test result okay, 35 tests passes. Then it runs the other tests in another file. It doesn't find any test there. It's okay. Test result okay. Then it runs the integration tests, which stays in other places, in another directory. Tests. And finally, when it finishes with all the integration tests, it says doc tests. And these doc tests is running 9 tests. These tests are taken from, look, test src macros line 42. So this line 42 is here, line 42. So this is the test it was running. So if in this test I say something like that, then all the tests will run first, integration test, unit test, everything will just work, except the so-called doc tests. You see it recompiles other things, because I changed the code. 35 tests okay, integration tests okay, everything is okay, except the doc tests. Boom, fail. See? So it says, boom, I can't find something, blah, blah, blah. So one of the doc tests, they fail. Very interesting, because you basically test the documentation which you provide to your users. And how did we start that? Yeah, we started by discussing from how this packaging happens in LaTeX. It's very interesting that you write the code, write the documentation all together, and then you ship it. Yeah, how we started, because the changes. I was telling you about the changes, and in this file, again, historically, because this format, the LaTeX, is very old, so historically they have it like this. They had it like this. The special command changes, it says my version 020, this is the date, that was the initial version. And then the version 04 something, and I did something. And then when it compiles all together, this is what you see in the end. And this is the format they, I'll show you now. This is how it looks. The final render, yeah, the change history. So they used to this format. It existed for ages in LaTeX community, change history. So now the world is changed. Now it's much better to say change history, look in my GitHub. But the entire community kind of used to having this page in the documentation. And that's why I have to use this text here. Even though I don't like it, it would be much better to just automatically generate this list here. Not to make me write it again, this change history, but to take it somehow from GitHub, for example. We have it already on GitHub. I already have this change history. I even have it more detailed. I have it with the links to the Git commits and everything. I even asked the people on LaTeX community who are developing this builder, like, can I get it automatically somehow? Maybe there's a plugin for that, some special command like this one, which will just take everything from GitHub and put it right here. But they said, just write it yourself. I mean, it's not so difficult, just a simple script, just connect to GitHub, blah, blah, blah. But it seems like this is the needing, this feature would be very important and useful for LaTeX community, because this is definitely the duplication of information. I have this information here, and I have it on GitHub. I have it in tags, I have it in releases, and I have it in this document. So in 3 places. It's completely redundant and completely, illogical to do it this way. But some people do it, and the community may push you this direction. I suggest you not to do it. I suggested it many times, never duplicate anything, because duplication of information is the source of the majority of troubles in programming. That's for sure. As long as you have 2 pieces of information in 2 different places, which is the same pieces of the same information, then you're begging for trouble, and you will have these troubles no matter, well, eventually. Most probably. So That's all I wanted to say about changes. So we will continue after a break, and we will discuss how to deploy to live servers, not to package storage systems, but to real live servers.